This is the event everyone's been waiting for, other than the door prizes, of course, for the discussion on UAS. The committee is honored to have 5 experts participating in our first ever panel discussion. Mike Battles will serve as the moderator, leading the conversation with the 4 panelists. Most of the folks on the table have a presentation earlier, so I'm not going to give the formal introductions again, but I do want to give a full bio read on Mike Battles and Matt Mercurio. So Mike Battles is Woolpert's Vice President and Practice Leader of Energy Services. Mike is a 4th generation oil and gas professional in the Ohio, Pennsylvania, and West Virginia region. Mike has facilitated the integration of geospatial technologies with engineering services at Woolpert to provide cutting-edge solutions to clients. This efficiency through technology has propelled Woolpert to become a national geospatial leader in the energy industry. Woolpert is a 100-plus-year-old architectural, engineering, and geospatial service firm, and was one of the first 4 companies in the U.S. to get an FAA 333 exemption. Woolpert has led geospatial services for manned systems for decades and will continue to invest in new technologies for the future of the geospatial industry. And for Matt Mercurio, some of you who were here last year might remember Matt was one of the presenters on the topic of UAS in just 2015. But for those who have not met Matt yet, Matt's 17th career as a GIS professional at nonprofits and in local government has attuned him to the critical needs of small organizations. He specializes in testing new ideas to carry out innovative approaches for solving tough problems in GIS and geospatial data management, and is now taking these innovative problem-solving ideas and skills into the business world. Matt co-founded 2 geospatial technology companies in 2015 and served as geospatial technology officers at both. He also provides professional services to several other companies and organizations that require assistance in the use of geospatial-enabled tool and data to maximize business efficiencies. Some of his current projects include development and commoditization of accurate ortho image products from drones, enabling geospatial technologies for emergency 911 service, and providing geodata management and development services for civil projects. Matt obtained his Bachelor of Science in Geoscience from Penn State and a master's degree in geology from Ball State University. So may I please present you Mike Battles, Mike Foley, Devin Humphrey, Dr. Srini Damapuri, and Matt Mercurio. Mike Mercurio.
Well, appreciate everybody. We've had some great presentations already on the UAS technology, so this should be an interesting discussion because I think a lot of information has been covered. So sort of going to break it up into 3 categories today. One, we'll start off more with the risk and regulatory side and some questions based around that. Second, we'll talk more about the tactical and implementation and the use of a UAV. And then third, we'll open it up to the crowd to ask some questions, as I'm sure you all may have some. So that's how we're going to get started. I guess I know we've done introductions, but I'd just like to ask maybe everybody to just go down and explain what your role at your company is when it comes to UAS technology, because I think everybody sort of has a different background to just again highlight that before we just start our panel discussion. So,
I'm Mike Tully, the President and CEO of Aerial Services located in Iowa. We've been a manned remote sensing and mapping operation for 50 years. And 4 or 5 years ago started looking at UAS, and my role there is just as the chief technologist to understand the capabilities and usability of these systems for our clients all around the country.
Devin Humphrey, I was introduced this morning, but I guess what got me into it was a frustrated GIS user looking for better data, more timely data, and it's just grown over time to where I'm doing less and less GIS, more and more UAS image content capture and processing and analysis now.
Yeah, my name is Srini Damapuri, and I'm with Michael Baker International of Pittsburgh, and we have been with the We have been providing UAV services for more than 1 year, and my role is primarily to support the program in selection of drones, cameras, sensors, as well as the data processing and the project management related issues.
So I'm Matt. Obviously, we get a nice intro from Harold earlier on. I was here last year, and basically we're about a year-old company out of Pittsburgh, and our focus is very much like Devin. We come from it from the mapping perspective for people that are not used to making maps or ordering maps. So we really are kind of a brokerage firm connecting people that need data to people that get the data, and of course UAS is the hottest topic now and produces the most data that needs to be dealt with. So that's kind of what we do, and my role there is to kind of go from soup to nuts, collect pilots, collect data, and then just deliver products.
Very good, thank you. So we'll start talking about the FAA, obviously the main regulatory agency out there that's overseeing the use of UAVs. From your perspective, I guess, what are the most impactful rules today that you see? For instance, I know the 400-foot ceiling, the pilot, line of sight, those are some things that have already been discussed. Is there anything else you would add as far as some of the FAA rules that people should be aware of from a risk and regulatory compliance side? Does that cover it all?
Yeah, I think it's just changing constantly. I think that's the biggest issue, is that people that are interested in getting into the technology, either at contracting or to do it internally, are kind of looking at a moving target. They're looking forward to when it's going to get easier in theory, or looking backward to when they wanted to do it a year ago. And it's really fluid right now, and having someone, or at least for me, I use pilots, they're really tuned in because it really affects their livelihood on a couple of different levels. So I think that's the thing, is it is a changing landscape, and you have to be on top of it. Otherwise, you're going to miss something that could potentially be very costly, or just kind of throw a monkey wrench in your long-term plans.
In addition to the standard requirements right now that are existing, one is, of course, if you want to provide UAV services, you need to have the 333 exemption, and you need to also have the COA certificate of authorization. And at the same time, with that, technically you can fly anywhere in the country below 400 feet, of course, with line of sight and other things. But what happens is there are some restrictions out there, which I think Mike covered yesterday. You have to be away from the roads 500 feet. You cannot fly 5 nautical miles from an airport which has a control tower, and 2 nautical miles with an airport which does not have a control tower. So what happens is, in this case, of course, the FAA has given a provision. So what happens is that you need to go to the next level of application, what we call it as a site-specific COA, or FAA calls as a full COA. It's a separate website, and you need to go and key in all the details, and it takes approximately 60 business days. That is what the website says, but sometimes it takes more time than that. So especially for an engineering company like us, I think with so much focus on transportation, I think this is something we need to work with that. So what happens is, it's a 2-level. One is the Section 333 and COA, that's the first level, and then you go for the next level, which is site-specific COA or full COA. So this is something whoever wants to operate the UAV, they have to go through.
So you kind of led me to, right, there's the hardline facts of certain restrictions and regulations. What are some of the softer things as far as experiences working with the FAA, and what are some advice you can give to folks that are maybe going to newly get into the use of UAVs and working with the FAA? What are some lessons learned, experiences you can share?
I guess one thing I might say is the big thing that's happening now is this interim rule is about to expire, we hope. Again, I premise that with the reality that we're talking about the FAA, a large government bureaucracy, and they're very, very slow. So they think and they promise, and we're pretty sure this time that they really are going to come out with a final rule here in about 30 days. By the end of June, they promise and swear it's going to happen. Maybe it will, hopefully it will. So that's a big deal, because most likely the 333 then becomes null and void. It's not important, and we don't need it anymore, and they won't exist. But we don't know that for sure either. Nothing we know for sure. But the big thing is, you don't have to go, you probably shouldn't start a to go through the exemption process. If you haven't already got one right now, wait for 30 days and see if this final rule comes out, and then go forward from there.
On the 333, it's kind of unclear whether it'll entirely go away or possibly remain for some of the, what I would call, for lack of a better term, high-end providers that are either operating beyond line of sight or larger systems. So there may still be a 333. But the other note I wanted to say on the 333, everyone seems to think in terms of commercial providers. Hey, I'm going to go buy some drones, set up a company, go capture stuff for GIS, and call myself a provider, get a 333. They're not the only ones that need them. If you have a utility company or a pipeline company, you're acquiring your own drones, your own assets, you need a 333 to operate, even though there's no money changing hands. The term commercial is kind of misleading. It probably should be professional use of drones. So it could be in-house with no money changing hands, and you need a 333. The other thing, back to the first question, the constraint, the biggest one for us right now is the beyond visual line of sight, which we cracked on one occasion for emergency response. But that will really open up a lot more applications, especially with corridors. The systems we're using, for example, they're military spec. They use them in Afghanistan. They can reach out 30 miles and control the drone. Well, right now I can't do that. The technology's there, the rules haven't kept up. So that's the constraint that I see at this point as the most impactful. I mean, we have to work with airspace. We have to have the 333, but that is keeping a cap or a lid on major use of drones.
Yeah, I've heard of a couple companies following their UAV with a helicopter to keep it in the line of sight. So there are interesting ways people are getting the experience per se, but not necessarily saving any money.
That's highly illegal, by the way, but
Yeah, that's specified.
Well, and that's why I want to start off with the risk and regulatory. I think it's very important for the audience to understand that there is risk. Firms have been fined and companies have been fined over $1 million by not doing it the right way. So sure, in rural USA, you may get away with it, right? And that's a risk you take. But if you get caught, it can be a significant fine. And I think right now the FAA, when they do find somebody, wants to make a point that they can fine you seriously to start to curb that. So I would highly advise to make sure companies of these calibers here in the oil and gas industry that we do this correctly. So
I think she wants to ask a question.
I just have one question. Is there a lobby group in behalf of, the professional commercial use of UAVs that can help with the FAA and other state regulatory entities?
we'll go ahead and answer this one, but again, we're gonna, towards the end, we're gonna take questions from the audience.
I'm sorry.
So if we can, let's hold that so we can get through, but we'll get back to that if that's okay. So give you guys time to think about that one. All right. One of there's the non-participant privacy, right? And have you guys at your companies created policies, or how are you addressing that? How are you communicating to the non-participants?
I think for us, we're just, I tell people that are trying to get to it from the beginning, pick a good first mission. Our first missions are nowhere near people. So we try to go into this with the idea that you want to get data or product out of it, and don't do the hardest one. Don't go fly a mall in the middle of somewhere that you know is going to be tough in terms of accuracy and everything else. Try to go somewhere a little simpler, so we try to stay away from those privacy issues, because I think what we've seen from working with other people in other countries, that drones are really good at taking pictures of dirt with nobody around. Everything else gets a little more interesting, so those kind of low risk area projects are the best ones that we like to work on, to introduce people on how to integrate drone data into their operations. It's a low risk in terms of data quality and low risk in terms of privacy. But we don't have one in place, but I think that it's to be required for most contractors. We're seeing more and more UAV addendums to contracts to specifically address that for the company that we're working for.
Okay.
I don't know whether that, whatever my answer falls under your question, I'm not sure, but one of the issues that comes with the UAV is getting permission from the property owner in terms of flying, and I think we have worked out some legal language, and there are times the property owner will give permission, but he would like to be protected or something like that. So as a company, we have gone through the legal process, made some standard language. So if the property owner gives access, then, we execute that document. So that way, I think, everybody is on the same page before we fly the drone.
It just so happens that the types of projects that we pursue and go after are naturally pretty much okay. Pipelines, wind farms, emergency response, that sort of thing. But as I mentioned this morning, ground control is not an option if you're doing really professional engineering grade, survey grade UAS work. So what does that imply? It means you have ground control points on the ground anyway. So you've had to receive right of entry from the landowner to do that. And so what we've done is we pass around a part of the ROE letter is that they're going to be allowing the use of drones over their property. We don't call it drones, we call it unmanned aerial systems. That makes it a little easier. And that we may need to go in to retrieve a system. So even if there's not a ground control point on that property, we have the right to go in, just like a hunter pursuing game on someone else's property. We have written permission to go do that.
Yeah, I'd just add to that the projects we've been involved with drones are pretty much already just with a landowner. So we've got the permission. We haven't had to deal with privacy. But think about that for a minute. 100% of us in America live on private property. And we intentionally pick projects for our drones that are that get around the need to notify the landowners. And so, like beyond visual line of sight, this restriction is very serious and a very big limiter on what we can actually do with drones, because when and if I do want to fly your neighborhood to update the county base layer with the latest the building and subdivisions, if and when I do that, I have to get permission from everybody underneath that aircraft, it just is never going to happen with a drone. I'll just take my manned aircraft and fly that today without any permission and be done lickety-split. But, so that's a big deal with drones, and it needs to change.
That manned issue was mitigated years ago as far as airspace and freedom of taking imagery with manned aircraft. That's not a question anymore. And the same thing will have to happen. I think that'll have to be litigated at some point where it opens things up. And it's really, again, FAA is concerned with safety, not privacy. So it's probably going to fall out of their hands.
Yeah, I know some of our clients, right, they look at their land agent and land agreements for the right-of-way agreements, and a lot of them say survey and mapping as part of it. So revisiting that language is something to take a look at as you start thinking about using UAVs as a potential data collector, if you will. One of the, this is kind of a fun story, and then we'll tie it back in, but there is conversation in DC as they try to figure out how do we move all of these UAVs across the country later, and would the pipeline corridors be the potential highway for UASs, because they are not developed on, if it were to crash, it'd fall in. So I don't know if you guys have talked much about that with your clients or anything, but I find that interesting. And again, some of our clients, again, when they're looking at their land agreements, saying, oh, New York City, they're selling airspace. Do we lease up the airspace now too? So it's become an interesting topic.
One thing that does bring up, the only place we've ever had any kind of airspace conflict was well within our 400-foot envelope. It's the pipeline patrols, the guys in the Cessnas that are cruising up and down the pipeline. They'll fly 300 feet, and they're not talking to anybody. They're not following a flight plan. And when we hear them before we see them, right? So we have our ears on listening for Cessnas, and when we hear one, we are able to just send the drone at a 90-degree angle away from the corridor and loiter and wait for the guy to go by. And we've had this happen a number of times. He's actually in our airspace, but we still have to watch out.
Okay, another question. We talked a little bit about getting the 333s and schedules, and just maybe walk through the typical requirements. So authorization, personnel, lead times, timeframes. Obviously the acquisition and turnaround of this data can be quick, but there's a lot of planning and stuff that has to happen up front. So if you could just discuss that a little bit. anybody.
It's like any data collection project, you know, so people think it's a drone, it'll do everything for it, but it's only 1% of the data ecosystem usually, so it has to fit with everything else. So the beginning is looking at what you're gonna update or what you're gonna look at fresh, you know, estimating that the size is key. You know, the size is key, and also vertical takeoff and landing constraints are key. Those are things that we look at for UAS, and also for I guess for the privacy thing too is for, we use small sites is what we like to do, so we use a lot of rotorcraft. So we have tight turnaround areas. We don't have to use a whole lot of overshoot to get the speed to turn around, so we have a lot tighter constraints in terms of what we can cover in the area. So we look at that, and really fuel is our primary constraint. You know, small UAVs, rotorcrafts are 15 minutes a shot, so you can do a big site, but you got to be considerate of that. And then I use professional pilots, so I'm always beholden to their schedule, but they have a pretty good schedule once they get up there into the ranks of the pilot folks. And then being on site, ground control. I think people forget how long ground control can take to set up if it's a unique site, and the distribution is going to be a little more difficult. That has to get done before you get there, otherwise you're going to be chasing your tail for accuracies. And those are the kind of things that keep me up at night if I'm preparing a drone flight.
In our case, what we have done is we have taken all the constraints that the FAA has put in place, like 5 nautical miles, 2 nautical miles, no fly over the military bases, no fly over the national parks. All those things we translated into a sort of Jira database within the company. So whenever internally or externally, whenever someone approaches me with a project, the moment I get a KMZ file or a shape file showing the project area, I do a quick analysis to see how best our COA is compliant, in the sense the project site is suitable for flying with the existing COA. I think most of the time, I think we can quickly make a judgment. Once with the GIS database, I can quickly make a judgment. Okay, it is more or less, it will be a go or a no go. And if it is a go, then I think with no time I bring the pilot into the mix with the multiple pilots present in the company, and they make the final determination, because with the GIS database, location-wise, I can tell, okay, it is suitable or not suitable, but the pilots will look into the airspace, Class A, Class B, Class C, D, and all. So those information they will, put into the mix, and, they will make the final determination to fly. The moment the most important thing is, whether our COA is compliant or not. I think that is the very biggest hurdle in any project. Whenever we get a project, if our COA is compliant, I think, we have almost solved half of the problem. And then the rest of the things, laying out the control, scheduling, those are all things, that almost most of the people who work on the mapping side of the business, they handle it on various projects. More or less the same logic works there. But the biggest thing over which everyone is really constrained is whether we can fly with our COA or not. That's all. That is the biggest question.
Yeah, I'll second that also. We use GIS technology to do our assessment, and actually it's all the way through our workflow from assessment. Of course, the customer, first thing they want to know is how much. But before I can answer that, I have to check the airspace and the constraints. But we also use the GIS in planning the ground control, mapping the ground control. It's all done with collectors, so we can go back and find those ground control panels. And then if it's a repeat mission, we reuse the ground control locations. So GIS manages all that part of the work. So we do spend a little time up front setting up the GIS part to manage the project all the way through delivery. And collector is a big part of that too, because a surveyor or a operator or a visual observer can go out with their iPad or their iPhone and go to their station and know that they're there. And it's repeatable that way.
Well, I think I saw 2 people nod, but legal is important. We all have to deal with it in our company. So that is just something that I think is important for everybody to take away, is the importance of the legality of using a UAS. It is not just going in your backyard with the Radio Shack drone and flying around mapping your pond or whatever. So if there's any other risk, that maybe I missed to ask that you guys would like to bring up.
Not so much a risk. Well, it is a risk.
Okay.
I don't know if anyone has heard about Esri's new Drone to Map.
Yeah.
It's a new application. It's standalone, not an extension. They're going to make a big splash with that this year at the user conference in about a month. And then you're going to have the risk of someone thinking, hey, I could just go get a drone from Amazon and do my own mapping and collect a bunch of pictures and fly around and have a lot of fun. throw it at some software, and out comes a good result. So the risk there is that A, they don't know the rules, and B, they don't know photogrammetry enough to get good results. So there'll be disappointment.
And I really think it's everybody's duty in this room to share this with your colleagues, right? Because I know at least with our company, you know, we understand, the geospatial folks understand this, you guys have heard this a number of times at seminars just like this, but it's your coworkers that might be out flying their own UAS, trying to look at a slip or something and try to, you know, get a video of that, and that's illegal to the point. And so I think we have an obligation to share this with our colleagues and be champions within our organization, so.
Insurance requirements.
Insurance requirements, and it's educational, right? So again, I think, again, we are experts, whether you feel you are not. I'd say what you've learned over the last couple of days makes you pretty darn good at what you're doing at this point compared to the rest of the world, so please do share with others. So moving on now, maybe more of the fun part, right, the actual flying and tactical and implementation, and I know over the last couple of days we've seen some really great deliverable products that you guys have been creating, and I guess just starting big picture, what are the greatest benefits you see for the use of a UAV in the energy industry? A very broad question, but what, as of today, where do you see the greatest benefit for this industry?
I would just say delivery on demand. The ability to capture quickly, process quality data quickly. So that means you can hit it multiple times during a project life cycle, during construction, for example.
Yeah, I'd say that, I'd agree with that. Safety also, it's gonna allow you to not put as many people in dangerous predicaments because you can do it with a drone.
Being working in an engineering company and also with a mapping background, when I started working with the UAV, my focus was mostly on the mapping side, specifically on the photogrammetric mapping and the LiDAR side. But as an engineering company, I've been asked so many questions, and I think slowly and steadily we are extrapolating, or we are going beyond the mapping side. Various inspections, it can be a tower inspection or it can be a bridge inspection. So those type of thing, which was not thought of earlier when we thought, it's going to be more like a survey grade or a mapping grade type of product we are going to get from UAV. But I think there are plenty of applications out there, or plenty of areas where we can use the UAV data. And the most important thing, as both of them said, I think, if you can fly the data quickly, that means the site is COA compliant, and I think then you can quickly do the job, very quick. If the site is near to your place, you can drive down and collect the data in a couple of hours, depending upon the size of the area. And then you can process in the next 4 to 8 hours if everything goes well. I mean, as you said, everything, always there will be some challenges will be there. I'm not telling it will be a very smooth or cakewalk or something like that, but there will be some challenges will be there. But I think once everything works out well, I think, you can get very quick results. What would be the application side of it?
So I tell my pilots I'm not a control freak, I'm a control aficionado. So control is really what this gets you. Industry gets you control of platform, control of sensor, control of delivery, control of timeliness. I mean, that's really what I saw as a GS practitioner, is that I was lacking some control that I knew I had knowledge of but couldn't actually express to the companies that were out there getting the data. So I tell people, why can't I get the GS manager for a long time? The question always is, why can't I go get it from somebody else? And I said, it's fine. Well, do you let somebody else run your checkbook? Well, it's about what level of control do you want? And this allows you to have more control than you ever had, as long as you have some knowledge behind it and have some great people doing the work for you. So I think that's what I tell people. Control, you're in control of many things of the project, and that's really good. I think it's good for the producer and good for the client.
Well, it's kind of, I'm going to talk about control, but a different kind of control that's been brought up already. So there's a lot of discussion, and again, the idea of relative and absolute accuracy and setting control, and how much control you set, and what is the right application. Are you moving Earth, or are you engineering from it? Is it for desktop planning? And so there's a lot of thought that needs to go into that. So I know we've talked a little bit about control, but I think that is another important part that we as geospatial leaders also need to communicate when we are acquiring these types of services. So anybody want to start the conversation on control?
Okay, let me make an attempt here. The real challenge I have seen is, on one side, within the company, most of the surveyors and those who are involved with the mapping, they have been gone through the old ASPRS standards. They're very clear about those type of things. So always, instead of going into the nitty-gritties, they will simply say that, finally, whatever the data you are going to give me, that should meet, 1 foot counter accuracy or 2 foot counter accuracy. That is what they will give me the requirement. But with the new ASPRS guidelines, which almost everyone would have seen, I think the new ASPRS guidelines has put everything in form of the GSD. That means whatever the resolution you are going to get, whatever the resolution you are going to get from the UAV, and I think that is what is going to play an important role in deciding whatever be the accuracy you are going to get. But as Mike yesterday presented, I think you can easily get 2.5 centimeters or 2 centimeters of GSD is very easily achievable. But then that puts a challenge in terms of meeting the requirement. At the same time, you don't overstate beyond what is possible. That is always a challenge I've got. On one side I have to make sure that the ASPRS guidelines are met. At the same time, I need to make sure that the client gets what he wanted. So that is a sort of a balancing act I have to do.
Qasim Abdullah works for Wolpert. He wrote an article in the ASPRS journal some time ago, and basically said that the state of the art today for accuracy, the best achievable accuracy is 1 to 1.5 pixels. So if your GSD is 6 inches, the best you can possibly get is 6 inches or maybe 9 inches, something like that. That's probably a good rule of thumb, but you have to remember that as far as this platform flying around goes, there's 2 ways to determine location. One is with your GPS device in the aircraft, and that's the least accurate measure of location. And then the other, if your aircraft has it, is an integrated INS. That second piece is very important, and if you need accuracy with your final deliverables, to get a platform that integrates both GPS and INS is extremely important, and it will improve the achievable accuracy of the final product tremendously.
Well, and we're talking in terms of a single capture, right? What if you have a project that you need to revisit a number of times? The importance of the ground control goes up, because if I want it to overlay properly, I need to be using hopefully the same ground control points, but at least the same accuracy of ground control project to project. And where this comes in for us has been on some 3D mining operations where I'm working for a large state agency in Texas that manages state lands, like the BLM for the state. They lease land for surface mining, pit mining, gravel, whatever. Right now it's the honor system, has been for 60 or 70 years. The operator turns in at the end of the year a statement how much they took out. Honest. Well, they want to capture it on a baseline in year 1, and in year 2 come back and capture it again, and with the 3D point cloud calculate the difference and subtract the difference. That's what was really taken out. Well, you can't even play that game if you don't have the ground control to match those data sets up. So that's another aspect of the ground control, not just on one mission, need it, but repeat missions really need it.
Yeah, I'd say, people always ask me how much ground control, I say yes. Do as much as you can, as much as they're willing to do for you, and then whatever you don't use it for control, you can use for checkpoints or do other things to help you assess your accuracy. So the distribution of points can be different for the site. So we like to, the ground control plan can cause people to actually go on site where they would normally not go on site in the past. That's a consideration. And and then that kind of directly applies to some of the different tactics. Is that your people are usually either on site or close to site, and that's different insurance requirements than other typical aero projects have along with them. This is something to consider, because there will be boots on the ground, and it really depends on the customer tells you whether you go outside the fence or inside the fence.
So that's just another thought real quick. For those of you that aren't familiar with accuracy standards and things like that, basically ever since we first made maps, there are kind of 2 levels of accuracy. One is you map and it's been tested to meet a specific standard. That's where you need ground control, and you're going out and you're actually measuring the earth, measuring the product you made, and statistically sampling the accuracy. That's tested. But the other one is map to meet accuracy guidelines. That's where all the processes and procedures and project design were such that it should meet this accuracy guideline, but it hasn't been tested. You don't know absolutely that it meets that, but it should if it was tested. So those two things are important ideas to consider as you design a project and determine how much ground control do I need. You're gonna need more if it's tested and less if it's just to meet that guideline.
Yeah, so again, I think we have a role working with our colleagues in our own organizations. Many folks that aren't in this room, but with companies that are in this room, we've flown UAS flights for your colleagues, and they don't know what a 2 or 3 centimeter pixel is, right? They don't know what kind of control it's often. Well, you tell us. So that defining that scope and really sitting down, we always try to pull someone from this room into those meetings, but that's not always the case. So again, I think this is very educational for us to spread this beyond this room in our organizations, because your companies are buying this technology, in some cases without the experts at the table helping develop that scope. So I would really encourage you guys to get involved. We've talked about accuracies. We've heard a little bit about beyond the line of sight operations. We joked around about the helicopter, and we had some scouts and observers out there, I've heard. What are other people doing with the beyond line of sight or the 1 mile restrictions, if anything, to advance the UAS technology? For instance, I'll throw out there, right, we take the UAS pod and put it on the Cessna for some of our corridor mapping. Using that technology, which isn't as accurate as traditional LiDAR, but is more cost and meets the spec. That's one way until the restrictions lifted that I know people are handling it. Are there other ways that you guys are handling it beyond what we've discussed here the last couple of days?
I think there's a couple big initiatives to do I get the acronym is DNAS-B, the idea of flight controllers in the air on these devices. I know that there's a bunch of research projects going on around that. That might not be specifically for beyond virtual line of sight, but it is good for people looking for COAs and people that are looking to get these devices just recognizable in the airspace, but also so that people forget that you get that picture too. So on your ground control apps, right now for the 300-foot flyers that are on power lines, you don't see them, but you could if they had a broadcast for their national airspace. So the Drone National Airspace actual airspace effort, airmap.io, some of those guys are out there helping folks integrate people that are already doing beyond line of sight traditionally with regular planes into their actual operations as a precursor probably to some sort of rulemaking that's going to allow for you to be aware of other aircraft operating in your particular area if you can't see your aircraft.
The FAA is actively engaged with a few companies now actually doing beyond visual line of sight operations. Precision Hawk, BNSF Railroad, and I think CNN are the third one.
CNN's over crowds.
Over crowds, yeah, that's right, yeah. So, the FAA is very engaged, I haven't used that word. They're exploring that. They're not moving very fast. So, and then of course, what we're all waiting for is some kind of sense and avoid technology or some kind of strategy technology that will be acceptable to the FAA and mitigate risk to the point where they're comfortable letting us fly these things outside of our line of sight. So they're doing some work with beyond visual, but hopefully after this final rule comes out, we'll see their tempo in this area increase and start working with folks like us to plan and figure out how to do missions, first in rural areas, then overpopulated areas with beyond visual.
All right, now we're going to go ahead and open it up to the audience, and if you want to go ahead and ask your question again, I apologize earlier.
That's okay. I'm just interested in whether there's some sort of trade association to help with some of the issues that y'all have been talking about.
There's a couple of them. There's one for what I call the big boys, the AUVSI, Boeing, Lockheed Martin, Northrop Grumman. There is a small UAS coalition that Elon Musk and some others are actually involved with for the smaller operators. So there are a couple of different ones that I'm aware of that are out there working. To be honest, we just stay busy and don't really have time to participate very much. So we're glad they're out there, but I don't know too much about what they've done.
Yeah, there's a third one we're associated with, MAPS is an organization, nationwide organization that basically comprises mapping and remote sensing and GIS firms. And they've got a real strong presence in Washington, and we meet with the FAA on all of these issues routinely and are kept up to speed and have some input. We sit on some ARC committees that are making policies and rules for UAVs, and they're quite effective and helpful.
Question back there?
Could you elaborate on the nature of the point cloud generated from UAS systems?
The nature of the point cloud.
Yeah, and where exactly is that coming from?
So the point cloud is generated using the imagery only, and it uses a statistical mathematical process to find every pixel in overlapping photographs. It tries to find the same pixel in each of the overlapping photographs, and using triangulation and mathematics and statistical processes, it can determine for every pixel that it finds in adjacent overlapping photos an X, Y, and Z location with good precision. And then it sorts all of those based on the probability that that's a good estimate, right? And so in the end, after it's done that for all the pixels and all the 1,000 overlapping images, it'll rank all those points, and it kind of throws out all those pixels that it couldn't get a strong correlation, a strong statistical probability that it's got a good location and elevation to it. And what you're left with is this point cloud, this three-dimensional point cloud. But the important thing to know about these point clouds that differentiate them from a LiDAR point cloud is the UAV point cloud is just the surface of things. So if only when you can see the bare earth do you get a bare earth surface that you could generate contours from. But if you've got any kind of vegetation or building covering the earth, then all you're going to get is a point cloud on the top surface of those things. Whereas LiDAR gives you both. LiDAR will give you the surface things and penetrate the canopy, etc., and give you the ground.
Just to supplement his answer, I think we have seen somewhere around 60 to 80 points per square meter. Of course, it depends on various parameters, the radiometry of the images, the land features that are present, and so on and so forth. But I think we are seeing a very good density of points obtained from the images. The other point, as Mike said, this is only a single return type of thing. So whereas the LiDAR is a multi-return. So what you get is, in the case of thick canopy, what you get is just only the top of the canopy, and in those cases, the elevation model, you need to make sure that it meets the accuracy.
Up front?
I was wondering if any of you guys had thoughts or comments about persistent surveillance. It was a pretty cool story that I heard about unmanned flights persistently surveilling a city. And actually, in this case, it was Mexico City, I think it may have been.
On Radio Lab.
Exactly.
Yeah.
So I don't know, maybe you can explain to the crowd if you know more what it is, first of all, and maybe what you think about it.
I think it's done at a couple of different scales. Citywide surveillance like that is one. It's probably going to be fixed wing.
I think it started in Iraq for roadside
Right,
bombs.
right. It's been done with balloons or inflatables, lighter than aircraft. There's also some new technology for rotors, believe it or not, because traditionally we don't think of rotors staying up very long, but there's a tethering technology for rotorcraft that will allow you to launch a rotorcraft. Say it's a large, in Austin we have Austin city limits on the lake, pretty big deal. They could launch a rotorcraft and it's tethered. The tether is supplying power for the UAV, so you don't run out of battery. Also has a 100 megabit data link coming down, so it's broadcast quality. So you could actually monitor traffic, monitor parking, monitor the crowd on a persistent basis with a rotorcraft in a small area, but it's tethered. That's how it stays up so long. But Google has some technology they're playing with for persistent observation. They started off doing it with bandwidth. They had the Loon program that was Raven balloons that had essentially Wi-Fi hotspots in the air. And they're just rolling this over into UAS.
That issue is a very interesting issue, and you have to think about it in a couple ways. One is who's surveilling? Is it Google or me, a private business, or is it the government? So if the government is doing it, then there's all kinds of issues with privacy that come into effect and may actually come into effect if I'm surveilling you also, right? You want to know that.
Privacy issue.
Well, there are several. Any technology you can think of can be used to great good and to harm, right? Persistent surveillance, it has been used in Iraq to save countless lives. It was used in Mexico to rescue kidnapped people. They could actually go back, rewind the tape, and actually see the kidnappers drive up and kidnap the person, and then they followed the tape back to where they came from and went and arrested them, right? Great use of technology. In our cities, we could, once a crime was committed, we could run the tape back and follow the people back to their homes and go bust them. But what all of us have to consider, what are the costs to our privacy for those good portions of the technology? Does the good outweigh the cost to our privacy? And that's a question we're all going to have to struggle with. There's no easy answers.
We've run out of time. I know these gentlemen will be around for a few other questions. Can I get a yes?
Yeah.
You guys, so apologize, but maybe here afterwards, when we break, we can answer some more questions. Want to give them just a quick opportunity to just give any kind of final statement. I would just start off with, again, this is a tool in the toolbox, right? So you got 3D laser scanners, you got mobile mapping systems, you've got traditional manned aircraft, you've got UAVs, and I'm going to forecast in 1 or 2 years, all the UAV discussion will be about satellites, and they're coming, and they're getting better, so keep an eye on those as well. So that would be my final statement, and we'll just go ahead and move it on down the...
Oh, well, thank you for the opportunity to be here. UAVs, like we've talked about, are great, promising technology. In one sense, they are just another tool, but they're a heck of a new tool that will become a great asset to this country and our businesses as regulation advances.
I'm just impressed with the interest and the level of questions that have been posed here today. I'm glad you're interested in it. Again, I offered this morning, email me anytime. I answer my own email, and that's to my detriment, but I do it, and I'm happy to talk to you about the topic. A quick note on the satellites. These micro satellites that are available out there now are very inexpensive to put up, like on the order of $1,000. So those things are coming. But interestingly, when we passed the drone privacy law in Texas in 2013 session, I pointed out to the guy who wrote the bill that the way he had his bill worded, unmanned aerial systems, that would include satellites. So a satellite is an unmanned aerial system for sure.
Okay, thank you for giving me the opportunity to the organizers. Only one line I want to say, this UAV is definitely, as everyone said, is one of the important tools, but it is going to, add more areas where we have not thought of. I think that is one of the important things I'm seeing with UAV. I think it is going to increase the horizons of the mapping side itself.
Yeah, just to extend what they said, the UAV is another tool, but they can produce that's more of a Swiss Army knife than when we used to have a knife. So we have a lot more data that's going to come off of these things. It's big. It's going to fill up your servers, find out how to use it, and data. This is one part of your data ecosystem. You got to fit it in and make sure it fits into everything else that you do. Otherwise, it's going to disrupt, and no one likes that. I can tell that firsthand.
All right, so let's hear it for the panel.